What up, athletes? Whoop, whoop. All right, let's get into this. We are in the quadratic. And our learning target today for 12.6 is, I will solve quadratic equations using the quadratic formula. I know, it's as if it appeared out of magic, or the power of pause, whatever, you know. All right, so first up here, it says evaluate the expression b squared minus 4ac given the values of the variables. And if you actually look down here, you'll notice that b squared minus 4ac isn't some equation we pulled out of nowhere. It's a part of the quadratic formula, which is right here. And it's the part actually called the discriminant. So we're just going to, without even knowing what the discriminant is, even though it's powerful, we're going to use it. So if I look up here, I have my b, which is, so that's just 2 squared minus 4 times my a of 1 times my c of negative 3. That's all I'm going to do, right? Go ahead and take a minute, pause this, see if you can solve 1 and 2 and 3. Ready, set, go. Okay, I'm assuming you've done that, so that's what? I'm just going to look at it. Here's 4, 4 times 1. So I got a negative, and a negative is going to make a positive. 4 times 1 is 4, times 3 is 12, 4 plus 12, so this equals 16. Boom, right there. Right here again, I have b squared, so that's negative 4 squared, minus 4 times a times c, which is going to be what, 16. And then just one minus sign, and 4 times 2 is 8. 8 times 5 is 40. It's going to be negative 24. Okay, perfect. And then last, b squared minus 4 times a times c. That's going to be what, negative 3. 2 negatives make a positive. 4 times 1 is 4, times 4 is 16, which is going to be 13. We'll come back and evaluate what these actually mean after we get to the next page. Super useful. All of this tells me something. Okay, let's go down here and look at the discriminant. Here is the vocabulary for it. That is not the vocabulary right there. Don't know why it reset like that. And the discriminant is the quadratic formula. In the quadratic formula, the expression under the radical sign that provides information about the roots of the quadratic equation. So that discriminant tells us about the roots. Take a minute, pause this, write that down, ready, set, go. And I'm assuming you paused it. I'm going to move on. You need to hang out on this video. Okay, so we have the quadratic formula, which is 4ax squared plus bx plus c equals 0. Then x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Thanks to a man named Mr. Cook, I can sing it like this. Negative b plus or minus the square root of b squared minus 4ac all over 2a. You know, pop goes the weasel, right? It's going to be stuck in your head now. All right, so let's go down here and start working some of these out. We look at this example right here, x squared minus 5x equals 84. The other day we practiced completing the square. Now I'm going to go the opposite direction. I want to move everything together. So this is really x squared minus 5x minus 84 equals 0. And then that makes a equal 1, because there's always a 1 in front, even though we don't see it. B is negative 5, and C is negative 84. This one we don't care about big numbers, because we got calculators. Calculators make us big and bad, right? So I'm just going to plug it right into there, so I know that my x equals, and it's important that you put x equals. Everything goes on the radical, or above the fraction bar, negative, and I put everything in parentheses pretty much. Negative b is going to be negative negative 5, plus or minus the square root of negative 5 squared minus 4 times a times c. Just got to extend all that all over 2 times a. This setup right here, by the way, guys, is worth most points if we're doing a test or anything like that. I'm going to give you tons. If there are 10 points on this thing, I'm probably giving you at least 7 on this. All right, just knowing you set it up right, because if you set it up right, eventually you can solve it right. So now let's solve it. It's going to equal positive 5, right? 2 negatives make a positive, plus or minus the square root of, that's going to be 25, And then, let's see, there's a minus minus, so it's going to be plus. 4 times 84 is what? 320 plus 16. So 336 all over 2. And let's see what this is. So I'm going to end up, now is where we're going to split into actual 2 different parts here. I mean, 2 different things we solve, right? There's 2 answers to every square root problem. One is going to be 5 plus the square root of, when I add those together, was that 56, 61, 361, the square root of 361, all over 2. And one is going to be 5 minus the square root of 361, all over 2. What is the square root of 361? Ooh, 19 came out exact. So this is which equals 5 plus 19 all over 2. 5 minus 19 all over 2. And I'll work this out in detail, although I usually cut some steps here. So that's just 24 over 2. And that is, what, negative 14 over 2. So this becomes 12 or negative 7. All right. And we really want to put x equals 12 or x equals negative 7. I don't necessarily need x. I need an x equals at the beginning. I need an x equals at the end. Because these are not just the roots 12 and negative 7. These are also the x-intercepts. So for x-intercepts, this would be 12, 0 and negative 7, 0. Right? That's where the quadratic is crossing the x-axis. All right, awesome. This looks like a lot of work. Honestly, when you get used to it, like even now, I haven't done it in a while, so it takes a while, but as you get used to it, guys, it starts going real quick. The biggest part is how to organize it. So when we look at our extra example 2, we got to subtract our 16x over this time. Make sure you put it in the middle. So this is going to become 4x squared minus 16x, and then minus 84 equals 0. We need it equal to 0. And then we get an a of 4, b of negative 16, and a c of negative 84. Take a minute, guys. See if you can set up the quadratic equation, that whole x equals, right? Ready, set, go. Okay, I'm assuming you've done it. So we're going to have x equals, big fraction bar, negative b, which is negative 16, plus or minus the square root of negative 16 squared. I'm sorry, the square goes on the outside. It's important that it goes on the outside because then you square the negative. So please forgive that. Minus 4 times a times c, which is negative 84, all over 2 times a, which is 4. Okay, that's the big setup. So now let's solve it out. We're going to have equals positive 16 plus or minus the square root of, and what's 16 squared? It's like 256 or something like that. Yeah, there we go. 256, and that's a minus minus. I always count my minuses ahead of time. If they're even, it's positive. If they're odd, it's negative. So that's plus. And what's 16 times 84? Because 4 times 4 is 16. 16 times 84. I did that right? 1344 plus 1344 all over 2a. Or 2a all over 8. It was 2 times 4. Goodness gracious. Now, here's what I actually do, guys. I'm going to do 256 plus 1344. That was times, my bad. 256 plus 1344. 1600, oh, that's going to work out nice. It's just going to be 40, right? So that's 1600 right there, right? And what's the square root of 1600? It's 40. So this is going to be 16 plus 40 all over 8, and 16 minus 40 all over 8. So it's going to be x equals. What's 16 plus 40? That's just 56. 16 minus 40 is negative 24. What's 56 divided by 8? That is x equals 7. Boom. Over here, I have negative 24 divided by 8. That's x equals negative 3. It is important we have the x equals at the end there. That matters for point value and for form. It's important you have the x equals here. It's important you have that fraction bar all the way under everything over this. Just keep that in mind. In fact, I've been known to throw in extra credit questions where if you get the form exactly right, but if you forget the x equals, or if that fraction bar only goes to here, it doesn't go under everything, no extra credit. It's got to be perfect. So, all right, let's go to the back side of this page. Let's finish this off. Let's talk about what the discriminant actually does, guys. So if b squared minus 4ac, if we come out with an answer that's less than 0, that means we're going to have 0 roots, which means 0 x-intercepts, like here, right? It's opening up, not touching the x-axis. If we have a discriminant equal to 0, it means there's going to be a double root. Which is 1 root, right? Like this would have 1 root at x equals 3. That's 1 x-intercept. If we have b squared minus 4ac is greater than 0, then that means we're going to hit the x-axis twice, so that's going to be 2 roots. Or as we see down here, 2 x-intercepts, right? That 1 and that 2. That's what the discriminant does. So if you ever want to know if something like is completely not factorable, then we throw in the discriminant and see what happens. So if I go look back at our warm-up, guys, let's see what it tells us. Okay, I had that 1 and 3 were greater than 0, so that means they are 2 roots, and this one that was less than 0, remind me, what is less than 0? It would be 0 roots. So this right here would not be factorable. It would be 0 roots. Okay? Awesome. Well, let's try one last problem, see if you guys can do it. In fact, I'm not even asking you to do the quadratic formula. Just find the discriminant, find out how many real solutions to the equation there will be. Ready, set, go. Awesome. Let's do this. I'm just going to add 3 to both sides, right? So I'm going to have 3x squared minus 6x plus 3 equals 0, which means my a equals 3, b equals negative 6, and c equals positive 3. Right. So we're going to do that b squared, right? B squared minus 4ac, which is just going to be negative 6 squared minus 4 times a times c, or 36, and 1 minus sign, so minus 4 times 3 is 12, times 3 is 36, which equals 0. And if it equals 0, what do we have? We have a double root or 1 root. So now to determine the number of solutions, there is 1 root. And just to prove that, guys, I want to show you what that looks like. I'm going to go ahead and do it. So I'm going to have negative b plus or minus the square root of b squared minus 4 times, what's funny is we already know what this equals, right? 4 times a times c. But I want you to see this 3 times c, 3, all over 2a. And here's why it only has 1 root, because we just determined this discriminant equals 0. So this is really, so that's positive 6 plus or minus the square root of 0 all over 6. Well, what's the square root of 0? It's just 0. That's gone. So there is no plus or minus. This is just 6 over 6, which equals 1. So I have 1 root at 1. That's why it works. Awesome. All right. Well, this is how to use the quadratic formula and the discriminant. With that said, peace out. Bye, guys.